This example is going to show us what we do when we divide complex numbers in polar form. So this is going to be a derivation very similar to the multiplication intro, but the upshot is that what we do is we end up dividing the moduli and subtracting the arguments. So let's see how we get to that. So if we're doing Z1 divided by Z2, then from here we can see that we have R1 cis theta 1 divided by R2 cis theta 2. And that's R1 into cos theta 1 plus I sine theta 1 divided by R2 into cos theta 2 plus I sine theta 2. Now, of course, when it's written like this, cos theta 2 plus I sine theta 2, that's really in rectangular or Cartesian form. Now think about what we do in that situation. We would multiply the top and the bottom by the conjugate of the bottom. So we've got our R1, cos theta 1 plus I sine theta 1, and I'm going to multiply that by cos theta 2 minus I sine theta 2. And then on the bottom, I've got cos theta 2 plus I sine theta 2. And we're going to multiply that as well by cos theta 2 minus I sine theta 2. Now on the top, what do we get? We've got cos theta 1, cos theta 2. So we're just expanding the brackets. Let's do this next. And we're going to get minus I squared. Now I squared is -1, so that's going to end up being a plus. Sine theta 1, sine theta 2. And I'm just going to stick a bracket around that because that's going to be the real part of the top. And then we're going to get plus I into sine theta 1, cos theta 2. So sine theta 1, cos theta 2 comes from that. And then we'll have minus sine theta 2, cos theta 1. Now the bottom is a difference of perfect squares. So we'll have the R2. The cross terms here will go. So what we're going to have is cos squared theta 2. And then when we do this, we'll get minus I squared. And I squared is -1, so that ends up being plus sine squared theta 2. Now, let's look at what we have on top. So when you look at that, you may recognize it, or you may go back and look, as cos theta 1 minus theta 2. And when you look at that, you may recognize that as the expansion of sine theta 1 minus theta 2. So on the top here, we have cos theta 1 minus theta 2 plus I sine theta 1 minus theta 2. Cos squared plus sine squared, of course, is just 1. We know that identity, and so the bottom just becomes R2. Now, looking again at the top, that's R1 cis theta 1 take away theta 2, cos plus I sine. And of course, that's over R2. And so we get back to what we had here. And we can see, just reiterating, that what we do when we're dividing is we divide the moduli, R1 divided by R2, and we subtract the arguments.